Okay, welcome to this video on plumbing and water. So in this video we're going to be looking at space heating, cold water and hot water systems as part of the Leaving Cert construction studies. This PowerPoint is obviously up on the website and it's also being sent out to you individually if you're in my class. Now, what we have is different types of water sources. First of all, we have groundwater, rainwater, and then we obviously have our treated water systems that gets pumped directly into our homes. Generally speaking, all water is treated, and even if that's coming from either a reservoir, lakes, or your own well, it will be treated in some form or fashion. You'll be learning more about that in geography. Both junior cert and leaving cert geography will talk into how water purification takes place. Same thing in science. However, for this, all you have to really understand is that there's rainfall, groundwater, and it's all treated coming into your premises. Home water system components. Generally speaking, you will have, unless it's your own personal well, a water meter, a water storage tanks up in the attic. Generally speaking, you have a water cylinder, you have pipework, valves, and fixtures and fittings. In terms of your water supply, you will have a mains water supply. This is a very large pipe that runs outside or adjacent to all houses in major cities, villages, and towns. If you're in the countryside, you're more than likely going to have a well. Then that leads into your water meter, a stop valve to stop any water coming back into the system. And then obviously you can see there on the right hand side, it then enters into the building itself. Now, cold water supply. We have two main types. You have direct cold water supply system and an indirect cold water supply system. Both systems are completely valid. Both systems work. There's one system that is more popular than the other, and we're going to look into the advantages and disadvantages of that. First thing to consider is direct cold water supply system. It goes directly to the fixtures. What it means by fixtures is it goes directly to your kitchen tap, your bathroom taps, your toilets, your showers, any of these components. Your indirect cold water supply system first goes to a storage tank in the attic, and then onto the likes of your bath, your toilets, your taps, and your bathroom. It is important to note though that your tap in your kitchen is still going to be a direct supply. Direct cold water supply advantages are as follows. First of all, you have very ease of installation. Okay, so it's very easy to install. You just run the pipes directly from the mains coming in to each of your individual components. It's a very low cost, okay, because you don't have excess pipework. There's no requirement for a large cistern in the attic. Bear in mind, every litre is 1 kg. So even that is 115 litres, that's 115 kg in the attic of water. It's quite a lot of water, but again, that's actually the small tank. We'll look into the bigger one now in a second. Drinking water at all taps, so this includes your bathrooms, your kitchens, every single tap, including your bath tap, they are all drinkable water. They're all coming directly from the mains. And obviously, like I previously mentioned, it has less pipework. As you can see there, you still have your stop valve and your drain valve at the start of this system. Stop valve is off to turn off the water. Drain valve is to help drain the system. Coming into all major appliances or fixtures, you'll also have the likes of a stop valve. As you can see there, going into the bathroom. Same thing going into the cistern in the attic. Cistern in the attic also fills with 115 litres, okay, and you just ball and cock there to stop it from overflowing. In case it does overflow, there's a 22mm overflow pipe. Coming out of that cistern, it then feeds into your heated cylinder. That provides you with hot water to your taps. Okay, that's the orange rectangle on the right hand side. That's your cylinder. That's what allows your hot water to be created. Direct cold water supply, there's obviously disadvantages to this. You reduce pressure at peak times. So this is generally in the morning and in the evening. That means when people are generally getting up, having showers, doing their dishes, cooking dinner, you're going to have less pressure coming through your taps. That's because most of the pressure will be going to other houses before you on the supply line. There's a high failure rate due to fittings due to the pressure. Most of these fittings will be under an exceptionally high amount of pressure. This means that over time, these fittings can wear down and leaks can occur. What we also have to bear in mind is if anything happens to the water mains, you will have no water at all coming into the building. That means if you lose water from the mains, so say a pipe has burst or anything else like that has happened, you will have no water at all. That means for your kitchen, your toilet, any of your taps, your bath, none of them. The only water you will have is coming from your hot water system, which is not drinkable, as we will discuss in the future. Now, moving on, we also have an indirect cold water supply. They obviously have some advantages. First thing I want you to point out or notice is that we have a mains coming in and still going to our kitchen sink. From our kitchen sink, it's then going up into the attic, up to a 230 litre cistern. You'll notice this cistern is much bigger than the previous ones. The reason this is bigger because this is then feeding into your toilet, your bathroom sink, and your bath. Okay, and obviously your shower as well. So that's then feeding into the rest of it. The only fresh drinking water that you have for this is going to be from your kitchen sink. All other taps you can't drink from. It does mean, however, you have a reserve of water, as you can see there by the first point. Because you have a reserve of water up in the attic, if for whatever reason you lose your mains, you're still able to get access to water to flush the toilets and to boil off water to try and make it into safe drinking water. It also means you will have constant pressure at all taps. You will not find that you will have a lack of pressure or your pressure system will drop. That's because you will have a constant supply of pressure from the attic. You also have an overflow prevention. So overflow there, you can see there as the line or the pipe coming off the cistern, which is at 22 millimeters. This will help prevent the system from overflowing. You can also see there again, you have your cold water coming out of your cistern and into the bottom of your cylinder for hot water. Okay, so that is going to be the very same thing as with your direct cold water system, except the only main difference is between you have a supply of drinking water and non-drinking water, and the advantages you see up on screen. Now this obviously comes with some disadvantages. The disadvantages of this is much higher cost. As you can see, we're adding in more pipework. More pipework means more labour, means more materials, which obviously means more cost. What we also have to remember is we have a very large water tank required in the attic. That's 230 litres or 230 kilograms of weight in the attic of water. Okay, and one of the main disadvantages with this system is you only have drinking water in the kitchen. Everywhere else you cannot drink the water from. So if the mains go, you will still be without drinking water. Now, hot water supply system. It's important to remember as well, with the hot water supply system, you can have a direct hot water and an indirect hot water system very similar to the cold water system, and both systems can overlap. You can have an indirect cold, direct hot, and so on and so forth. These systems overlap. That is no problem at all. Now, water can be heated by appliances, most commonly known as boilers, back boilers, or immersions. Generally speaking, the boiler will be in most people's houses, and that will be made of gas or oil. You'll also have an immersion in most cylinders. So most hot water cylinders that you'll find in all premises for showers, unless you have an electric shower, will contain an immersion. Think of this like a giant kettle. There's two different types of hot water systems. You have direct hot water system, water to boiler, direct from cistern and attic. But you also have an indirect hot water system. Water to boiler is fed directly from secondary cistern and attic. So basically what this means is you have hot water coming into the boiler, direct from the cistern in the attic, and in the indirect system, you means you have a secondary cistern. This means you have a constant supply of water. There's advantages and disadvantages for both again. Now, the direct hot water system looks like this here on screen. What we have is our 230 litre cistern coming out of the attic. Okay, that goes into our cylinder, and you notice how we draw this. We have a red line, so that's our hot water coming out of the top of our cistern. You'll notice there it goes off to the left hand side, and it goes to our bathroom sink, and our kitchen sink. You'll also notice a red line going straight up to our cistern. That is an expansion pipe. Okay, so if pressure builds up too much into our system, that is an expansion pipe. We want to ensure that expansion pipe is there to ensure that nothing untoward happens or that there's no explosion or buildup of pressure. Okay. What we also have down in the bottom right, you can see there we have a boiler. It also says there as a thermostatic control. Basically means it's going to cut off at a given temperature. Most of us humans, we can't go along and have a shower in 100-degree water. That is steam. What we generally have is about a 40-degree shower, if not 38. So it's important that we don't overheat the cylinders. That's where the boiler comes into place. You'll also notice on the measurements for all these pipes that the main primary flow from the boiler is at 28 millimeters. You'll also notice that the majority of other pipes around are at 22 millimeters for hot water. This is done on purpose. You want a larger feed pipe for water, especially hot water, due to the expansion of water. Now, let's have a look at some of the disadvantages for this. Radiators cannot be added to the system. You also have a massive strain on the boiler, as the boiler is constantly heating that water, and it's very expensive to run. As you're constantly boiling water, there's going to be a build-up of limescale. This limescale is going to clog your machines, your boilers, your cylinder, and eventually clog your pipes. And it's going to be a very costly repair. This is why this system is very rarely used here in Ireland. And we prefer to use the indirect hot water system. This is because it has a number of advantages over the previous one. It has advantages such as reduced stress in the boiler, no limescale buildup, and radiators can be connected easily to the system. As Ireland is generally a cold country, we want radiators connected to our systems. So, like in the previous image, everything on the left hand side stays the same. We still have our 22 millimeter feed pipe coming off to our bathroom sink, and our kitchen sink. We still have the same thing, our 230 litre cistern in the attic, and we have our hot water expansion pipe coming up to that. So that entire system stays the same. What we'll be looking at in the future when I get a drawing up, there will be another video on this, on how to draw this out, is why that is. So you can draw these in two separate parts. You're then looking at your space heating and your hot water heating system on the right hand side. You see there our boiler. The main difference with our boiler is we also now have an expansion vessel. So we have now our expansion pipe, should I say, coming up to our 45 litre cistern. That's a second cistern in the attic, only supplying water to the boiler. As you can imagine, as you boil water, you're going to go along and create steam, and you're going to have to replenish that water. As you can see there, the cold water feeds into the bottom of the boiler, hot water comes out. You can now see a zigzag in the hot water cylinder. That cylinder creates a secondary heating system inside that cylinder. What I mean by that is the water from the left hand side, so our 230 litre cistern, does not mix with our boiler water. They stay separate. What's inside that is a bunch of copper coils going around that cylinder, and it creates heat by radiating out. So as the hot water travels through these copper pipes, it's transferred into the water into the cylinder, hence reducing the likes of our limescale buildup. And once the water is cooled or gets cold, it's then brought back to the boiler, reheated, pumped back into the cylinder. Again, to prevent the likes of explosions or having too much pressure, we have an expansion pipe going up to that 45 litre cistern. You'll also see there's an overflow. Overflow again is important to make sure that if for whatever reason the ball and cock in the actual cistern breaks, we have an overflow so it takes all that water away. Now, there is obviously some disadvantages with this system. There's extra storage tanks necessary, so that's going to be an additional cost to you. You have higher installation cost due to more pipe work. So this means you have to pay for more labour, more piping, and obviously it's going to cost you that bit more, but generally speaking, most people will believe the advantages outweigh the disadvantages for this. Solar, we will look into again into the future. Okay, that will be another separate video. And same thing with geothermal. These come up quite often and even start questions, so we're going to dedicate a video to them by themselves. Now, we have two types of systems for our hot water or space heating. So we have cold water covered, hot water covered, and now what we're going to have a quick look into is our space heating. So we have an unvented system, so it's connect hot water cylinder to the mains instead of storage tanks. So unvented system is going to be very, very similar to our other two systems. Now, what you will notice here with this is with the unvented system here, it does not require a cylinder in the attic. It also means it's going to be a direct supply system without our 115 litre cistern in the attic. What we will have instead is an expansion vessel. You'll notice your mains are still coming into your building and still going to each of your surfaces, your fittings. This time you will have an expansion vessel. The reason for that expansion vessel is if the pressure is built up too much, you'll see there's also a pressure reducing valve. If pressure is built up too much in the system, it'll go into the expansion vessel. And from there, it'll expand. Okay, we'll have a look into how these work in a few minutes. But take your time and have a look at the image here in front of you. On the right hand side, you'll also see there's no cistern, our 45 litre cistern for the boiler. That's again is because we have an expansion vessel. You'll also now see that the radiator is hooked up to the system, and that's going to be at 22 millimeters flow and 22 millimeter return. So these are big pipes to allow the flow of water through all the radiators around the building. You'll also see in between the two, you'll see these dotted blue lines. That's a temporary filling connection. Generally speaking, that will stay in place with your stop valves, your check valves, and your filling valves all there stuck in place, just in case for whatever reason you need to refill the system if ever there is a breakage or a leak. Again, if the pressure builds up too much in the boiler system on the right hand side, you're going to have an expansion vessel. What you're also going to notice above the cistern, or above the cylinder should I say, you have an anti-vacuum valve and you also have a temperature release valve. We're going to have a look into what they actually do. They're really important, as in if we have a temperature build-up in our actual cylinder that is too great for the system to handle and may cause pipe breakages, leaks and explosions, your temperature relief valve and your anti-vacuum valve will release that pressure as part of steam or water going outside the building. Now, having a look at our expansion vessel and our temperature release valve. These two of the safety features that must be used for an unvented system. So far, everything up until the last image was a vented system. That's because it had the expansion pipe going up into the attic, into that cisterns, and out of the building, or back into the building, should I say. Now, expansion vessel, it basically is this giant steel cylinder. Inside the steel cylinder it has a diaphragm, which is a rubber balloon. There's also an air or nitrogen cushion. It's generally just air. But some of the more expensive ones, depending on how big your system is, will be nitrogen cushion. What happens is as the system expands, you'll also see there, as the images go from A, B and C, you have water expanding into the diaphragm. As more and more water fills that diaphragm, the expansion vessel starts crushing down on that air. The balloon starts to expand. That'll keep going until it fills the entire chamber. If it does so, then we'll also have to release pressure another way. But however, generally speaking, expansion vessel is completely perfect. Temperature release valve. As the temperature builds up, you can see there you've locked, unlocked and venting. As the temperature and pressure builds up into the system, you'll notice that as the pressure will build up, it'll start to push up on the locks. So it'll push it up, it'll unlock it, and once it is unlocked, it'll start to vent. The reason for this is to allow that pressure to escape. Heating, you have one pipework and you have a two pipework system. One pipework has been now phased out over the last number of years, and generally speaking, we'll only be looking at two pipework for future buildings. That's because of the advantages and disadvantages of each. Generally speaking, one pipework is used in older houses. You have advantages such as very low cost, ease of installation and low maintenance. However, you have the disadvantages of temperature difference in the radiators and reduced control over the radiators. As you can see there with one pipework, you have a hot water coming into one radiator, out of the same radiator and into the next. This is going along creating the first radiator very, very hot, and by the time you get around to the last radiator, most of the heat is actually gone. Unlike in the two pipe system, what we have is each hot radiator is connected up. So as you can see, the hot water goes into one side of the radiator and into this one side of the next radiator. You'll also notice that the cold water comes out of the radiator and they stay as separate pipes. That means the water from the first radiator goes into the first radiator and then back out of that radiator. That can then get sent straight to the boiler to be reheated. Same thing, you can follow the arrows the whole way around, but this goes along and creates a continuous stream of hot water to every single radiator. This means radiators operate at the same temperature. Every single radiator starts heating at the same time. It also allows for greater control over individual radiators. You can close off your control valves, and once those control valves are closed off, you can change the temperature of your radiators. The advantages or the disadvantages of this is obviously it's going to cost more. More pipework, more labour means increased cost. However, that does also mean it's going to be longer to install. But the benefits generally outweigh the disadvantages of this system. We'll also look into underfloor heating at a later stage, but please note it is on the PowerPoint. This is the image we will be looking at for our video. So please have a quick look over it, and this is what the next video will be on.